Hello everyone. So we're going to continue with last lesson, Newton's second law of motion, which will tell that F is equals to mass times acceleration. But today we're going to look at how to use this formula in motions in two dimensions, which we are given vectors I and j. So still similarly, so let's have a look at a question together. So in this question, I represent the unit vector due east, and j represents the unit vector due north. So a resultant force of 3I plus 8j act up on a particle of mass 0.5 kilogram. Find the so part A, we want to find the acceleration of the particle. So again, let's start with the formula. So we have F equals to mass times by acceleration. So we know the resultant force, which is F, it's 3I plus 8j. It's equals to the mass. So the mass is 0.5. And we don't know the acceleration, so we want to find out the acceleration. So so we have the equation, so it is solving our equations here. So 0.5 multiplied by a is the same as half a. So 0.5 is same as half. So to find a, we just multiply it by 2 on the other side. So multiply the whole thing by 2. So our acceleration is equals to 2 times 3 is 6I. 2 times 8 is 16j. So our acceleration is 6I plus 16j. So let's look at part B. Find the magnitude and the bearing of the acceleration of the particle. So to find the magnitude, let's start sketch our diagram. So we are going 6. So we are finding the magnitude and bearing of the acceleration. So this is our acceleration vector. So we are going 6I, so 6I this direction, and 16 up, so 16j. So this is our resultant. So this is the magnitude we want to find. So we want to find out this magnitude here. And to find the magnitude of the acceleration, so again, remember from before, this is how we write our magnitude. So magnitude of the acceleration is equals to, so again, this is just another Pythagoras question. So this is a right angle. So if we remember Pythagoras, would be 6 squared plus 16 squared square root. So we know that the magnitude of A is equals to 17.1 meters per second squared minus squared, and this is your answer just simply by typing into your calculator. So this is your magnitude. Then we want to find the bearing of the acceleration. So again, so if we remember to find the bearing, is we always start from north, and this is our resultant. So we want to find out this angle here. So this is the angle we are interested in. As we can see here, we can find out this angle here first. and subtract because this is a right angle. So let's find out theta first. So theta is this little part here. So this is theta. So find out what theta is. So theta would equals to, so we're going to use our SOHCAHTOA again. So label our sides. So this is hypotenuse, opposite, and adjacent. So we're going to use our tan. Theta is equals to the opposite, which is 16, over adjacent 6. So tan theta is equals to tan minus 1, 16 over 6. So type into your calculator, you should get that theta is equals to 69.4 degrees. But what we are interested in, we're interested in this angle here. So we need to do 90 subtract 69.4, which is equals to 20.6. But remember, when we're writing our bearings, we need to write it as 3 digits. So our bearing is 0 to 0.6. So let's look at the second example. We have force 1, which has the vector 2i plus 4j. Force 2, minus 5i plus 4j. Force 3, 6i minus 5. Act on a particle of mass 3. So again, we always start by writing out Newton's second law. So force equals mass times by acceleration. So to find out the resultant force, so we learned from last few lessons ago, we need to add all the force together. So I prefer to write them out in the column method. So force 1 is 2, 4, plus force 2 is minus 5, 4, plus force 3 is 6, minus 5. And this is equals to mass, which is 3, multiplied by acceleration, which we want to find out. So let's add them up. So 2 minus 5 plus 6 is 3. 4 plus 4 minus 5 is again 3, which is 3a. Therefore, we know that acceleration must be equals. So we need to divide the whole thing by 3. So as we remember this, it's 3i plus 3j. Now equals 3a. So we now need to divide the whole thing by 3. So acceleration would just equals to I plus j. So let's look at the last example. A boat is modeled as a particle of mass 60 kilograms, being acted on by 3 forces. So still, similarly to previously, so find out our resultant force. So to find out the resultant force, we need to add the 3 things together. So resultant force would be force 1 plus force 2 plus force 3. So force 1 is 80, 50, 10p, 20q, plus minus 75 and 100. So add them all together. So 80 plus 10p minus 75 would equals to 5 plus 10p, and 50 plus 20q plus 100 is same as 150 plus 20q. So given that the boat is accelerating at the rate of 0.8 minus 1.5, find the value of P and Q. So again, we're going to use our formula. So F equals to ma. We know the force, resultant force is 5 plus 10p, 150 plus 20q, equals to mass. So we thought the mass is 60, multiplied by the acceleration, which we have here, 0.8 minus 1.5. So multiplying our vector out, so 60 multiplied by 0.8 is equals to 48. 60 multiplied by minus 1.5. So remember, let's just write this out. So multiplying our vectors would be 60 multiplied by 0.8 and 60 multiplied by minus 1.5. So just type into your calculator. You should have 48 and minus 90. So we have our equation here. So let's just write this closer. So 5 plus 10p, 150 plus 20q is equals to 48 minus 90. And we want to find the values of p and q. So remember, those are equal. So remember, this is our I. So let's write our I up. So those two will be equal. So 5 plus 10p is equals to 48. Therefore, 10p is equals to 43. Therefore, p is equals to 4.3. Then we're going to look at our vector j. So we have 150 plus 20, q equals minus 90. So 20q would equals to minus 240. Therefore, q is equals to minus 12.